Assalamu alaikum class, and today we are going to do the practical of separation of proteins by isoelectric pH method. Now the proteins can be separated by many different methods, and one of them is the method using the quality of protein to have isoelectric pH, and we use this property of protein to separate different kinds of proteins in the biochemical way. The other methods include separation by different qualities. Now, what is the isoelectric pH of protein? It is the pH that at which the molecule of a protein or amino acid possess no net charge on it. So at this pH the solubility is minimum and the precipitation of that amino acid or protein will be maximum. So the precipitates will be formed and that protein will be excluded and will be identified separately from the solution. So the next heading will be given of procedure, in which the given solution containing 0.5% casein solution in 0.1 molar sodium acetate solution will be taken, and now 9 test tubes will be taken and will be labeled as 1 to 9, and into test tube 1 3.2 ml of 1 molar acetic acid solution will be taken, and then into it 6.8 ml of water will be added, and these two constituents will be mixed in test tube number 1. Into all other test tubes 2 to onward 9, 5 ml of water will be taken. Now take 5 ml of solution from test tube number 1 and transfer it to test tube number 2. Mix and transfer 5 ml from test tube number 2 to test tube number 3, proceeding in this way till test tube number 9. In this way, all the test tubes will come to have 5 ml of acetic acid solution, and each succeeding test tube will have half the strength of acetic acid as compared to the preceding test tube. To each of these test tubes, 1 ml of given solution will be added, that was in detail told in the first line. Now mix and note the solution becoming turbid at once. Now let the test tubes stand for 30 minutes and look for any sedimentation in all the test tubes and record the result. Now the pH of each test tube is measured by Henderson-Hasselbalch equation, and each test tube has 1 ml of 0.1 molar sodium acetate and different amounts of 0.1 molar acetic acid. Now pH of the test tube in each test tube is ruled out by the following equation that is shown here. The pH will be equal to pKa of that protein plus log of salt over acetic acid. Now pKa for casein is 4.7 plus log of salt and acetic acid in that test tube in which there is maximum amount of turbidity and maximum amount of precipitation, that is test tube number 5. Now the amount of salt and amount of the acid, the value of amount of acid and salt is put in this equation, and the result is obtained in the form of 4.7, and this 4.7 is the basic isoelectric pH of casein. So at this pH the casein molecules will be having isoelectric pH and will be having the highest tendency to settle down in the test tubes and minimum tendency to be dissolved. Now the table is to be written on the white page side of the practical notebook, in which there will be 9 columns and 7 rows. Now the first row, the labeling of the test tube is done from 1 to 9, and in the second row there is 1 molar acetic acid in ml quantity is given, and this 1 molar is converted to 0.1 molar acetic acid solution to do the basic comparison with the normal given solution, that is sodium acetate solution. Now first we will take in test tube number 1 1.6 ml of 1 molar acetic acid, that when converted to 0.1 molar will be 16 ml, that is shown in the second row. Similarly, in test tube number 2 there is 0.8 ml of 1 molar acetic acid, that when converted to 0.1 molar is 8 ml, and similarly in test tube number 3 0.4 molar acetic acid solution when taken as a 1 mole is written, and when it is converted to 0.1 molar acetic acid in ml it is 4 ml. Similarly, up till test tube number 9 the amount of acetic acid is written, that is successively in diluted form, and in each succeeding test tube it is being diluted by further half amount. Now in all the test tube the standard 1 ml of all the standard solution of sodium acetate is given drop by drop, and the pH by Henderson-Hasselbalch equation in each test tube is determined by applying the formula of this equation and putting the pKa value of casein. And turbidity in test tube number 4 is more than test tube number 3, but maximum in test tube number 5, and sedimentation in precipitate formation is also maximum in test tube number 5. So most likely this is the isoelectric pH of the given protein, that is casein, at which the casein has the highest tendency to get precipitated. And when further in test tube 6, 7, 8 and 9 the tendency to precipitate and sedimentation is not more than test tube number 5. So the pH of test tube number 5 is the isoelectric pH of protein casein, and similarly we can differentiate the other proteins by finding out the isoelectric pH of that protein, and at this pH the protein will have the highest tendency to precipitate and will be isolated from the other solutions.